We're now at the activities portion of lesson 11 for Math 107. Question 1, by the definition of a function, each value of x can have at most one value of y. Based on this definition, how many x-intercepts can a function have? So this is many, right? Or none. So each value of x can have at most one value of y. So if I look at a quick x-axis here, if I have many x-intercepts, no matter how I connect them, right, something like that, this is still going to pass the vertical line test, not hitting more than 1 point for any vertical line. But for y-intercepts, if I try to draw a picture where I have more than one y-intercept, I have immediately failed the vertical line test, no matter how I connect them, right? This one spot right here now fails the vertical line test. So a function can have 0 or 1 y-intercept. If it has more than that, it fails the vertical line test and it's not a function. Question 2. So we have some pictures of a time, temperature, flu scenario. We've got hours after 8 a.m. on the x-axis and the temperature of a person with the flu on the y-axis. Over what time interval is the temperature decreasing? Okay, so we're looking for when the temperature is decreasing, and that happens from this point here to this point here. The graph is heading downhill, right? If you want to look at the whole time scenario from here to here, so that's from 0 to 3. And if we're talking hours after 8 a.m., so 0 would be 8 a.m., 3 hours later is 11 a.m. So over what open time interval is temperature decreasing? And they actually asked that values for x be given in the number of hours after 8 a.m. So I'm not going to translate them to times. We're just going to give hours after 8 a.m. So we're decreasing from 0 to 3. And remember that an open interval means that the endpoints are not included, and they asked for an open time interval. So we're not including 0 or 3. Over what open time interval is the temperature increasing? So temperature increases from this point right here until this point right here, and we only give time, right? So when you're describing an interval for increasing or decreasing, you only give the x coordinates. So from 3 to 5 hours after 8 a.m., the temperature is increasing. So it would be from 11 a.m. until 1 p.m. Over what time interval is your temperature remaining constant? So that's this last little piece here, from hour 5 to hour 7. And again, we're giving an open interval, so we put 5 to 7 with open parentheses. At what time is your temperature the lowest? That happens at our minimum, our relative minimum right here. And they've only asked for the time, so I only have to give the x coordinate 3. Okay. So I would accept hour 3, right? Or 11 a.m., right? 3 hours after 8 a.m. So this temperature flu scenario illustrates that the ideas of when a graph is increasing, decreasing, and constant are fairly intuitive. Your textbook gives a more formal and precise algebraic definition of these ideas, but just remember that you always describe increasing, decreasing, and constant with an open interval of x values. You don't include the endpoints. Relative extrema, that happens when a function changes from increasing to decreasing, or vice versa, decreasing to increasing. So we have a relative maximum or a relative minimum. Think of it as a peak or a valley within a mountain range. It is not necessarily the highest or lowest point, but in its region, it's the highest or lowest point. All right, we just got a bunch of questions to answer about this graph of f. First, I want to give its domain. So those are the x values where the function lives, smallest to biggest. So because I have these arrows down here, they indicate that the graph continues down forever, but also they are widening, right? So it actually is heading left and to the right forever. So my domain here is negative infinity to infinity. And then the range, the lowest y value is going to be negative infinity because those arrows go down forever. But the highest y value is 4. So we're going to go negative infinity up to 4. So I'm just giving the y value of that highest point here. And that point is included on the graph. It's not an open circle, so I include it with a square bracket. The zeros, those are x-intercepts at -4 and 4. And f of 0, that is an x value of 0, and they're asking for the y value. So that would be right there. So f of 0 is 1. Intervals on which f is increasing. So that is, read the graph from left to right and list intervals where the graph is, where you're climbing uphill if you're reading from left to right. So this portion of the graph is increasing because as you go from left to right, you're going uphill. And then after that, we're decreasing for a little bit. That portion's decreasing. So decreasing will be in pink. And then we start increasing again on this interval. So increasing is in purple. And then we decrease again, pink. So for increasing, I just want to describe the purple intervals I've highlighted. So we're going to only give x values. So this goes down into the left forever. So I'm going to start with negative infinity. Right? And then it goes up until this point right here. Up until this point, function's increasing. And I only want to give the x value of that point, which is -2. And when you describe increasing and decreasing, you always give open intervals. So we put parentheses on the ends. Then there's another place where the function is increasing. So I put union, and I list my other interval where I'm increasing, which is this second purple interval here, which starts at x equals 0 and finishes at x equals 3. So I put 0, 3. And then for decreasing, those are my pink intervals. This one here, which starts at -2 and goes to 0. There's my first decreasing interval. And then my next one starts at 3 and goes to infinity. So I'm going to write those down. I have -2 to 0, unioned with 3 to infinity. Values for which f of x is bigger than or equal to 0. So f of x is y, right? See right here, y equals f of x. So I want to know, when is y bigger than or equal to 0? So that's when are the y values positive or 0? So here they're 0. And then when they're above the x-axis, they're positive. The y values are positive. So it goes from here, -4, all the way until here at 4. Everywhere in between, the y values are positive or 0. So I'm going to put -4 to 4. That's where they're positive. They are equal to 0 on the ends, and I'm asking about or equal to 0, so I include the -4 and the 4. All right, a relative maximum. So I have 2 relative maximums. So I've got one here and I've got one here. So I'm going to fill in this sentence. A relative maximum is and occurs at blank. Okay, so the maximum value, the maximum is the y value, and it occurs at the x value. So the maximum, if I look at this one, the y value is 4. So it's got a maximum of 4 that occurs at -2. And then my other one right here, it's got a maximum of 2 that occurs at 3. And then my relative minimum is right here, and it has a value of 1, and it occurs at x equals 0. The values of x for which f of x equals 3. So I'm looking for x values. They've given me a y value of 3. So find a y value of 3 on the y-axis and see what points on the graph have a y value of 3. And it looks like, draw that a little better, here and here, -3 and -1. And is f of 5 positive or negative? So I want to find x equals 5, which is right here. Go down to the graph, and it's not, I can't hit the graph, but I know that it is negative because I'm below the x-axis. All right, so I have some function formulas, and I want to classify each function as even, odd, or neither. First column is done. So in the first column, I just test a couple numbers. You want to check one positive and one negative of the same value. So I like to use 2 and -2, or 1 and -1, because smallish numbers are easier. Now, if you get that the two, for the opposite x values, you get the same y value, then f may be even. And if you don't get the same y value, then it's definitely not. You can conclude that. And if you plug in opposite x values and you get opposite y values, then f may be odd. And if they're not opposite y values, then it's not odd. All right, so you can read this first one on your own. I'll do the second one with you. All right, so for x squared, I'm going to do f of -2 and f of 2. See what I get. Okay. If you put -2 into x squared, that means -2 times -2, which is 4. Put 2 into x squared is 2 times 2 is also 4. So I got the same y value. I plugged in opposite x values. I got the same y value. So f may be even. And a function cannot be both even and odd, so I'm not even going to check odd. So f may be even. So make a conjecture based on the tested number, right? We think that this might be even. Then I have to prove that it's true, not just for 2 and -2, but no matter what set of opposite x values I plug in, that I will always get the same y value. I can't just I can't test every positive and negative x. I could do a few more if I want. I could do 1 and -1, 3 and -3, 4 and -4, 5 and -5, and see that I keep getting the same y value, but you can never test all of them. So we have to do it with a generic x value. So I have to prove my conjecture by looking at f of x, which is x squared, and f of -x, which is -x squared, which means -x times -x, which is positive x squared. So now you see you get the same y value for generic opposite x's. So we can conclude that x is even, that f is even. All right, let's look at another one together. Part B. So I have f of x equals x cubed this time. So try opposite x values. So f of 2 and f of -2. So 2 cubed, that's 2 times 2 times 2, that's 8. -2 cubed, that's -2 times -2 times -2, that's -8. They are not the same y value, so we know that f is not even, okay? But they are opposite y values, +8 and -8. So f may be odd, right? That's my conjecture. F may be odd based on the opposite x values give opposite y values. Then I have to prove it, right? So I have to prove it for every possible pair of opposite x's. So f of x is x cubed. F of -x is -x cubed, which means -x times -x times -x Negative times a negative times a negative is a negative x cubed. So you can see you get x cubed for when you plug in positive x, and you get negative x cubed when you plug in negative x. So those are always going to be opposite y values. All right, last one, x cubed minus x squared. Start by plugging in 2 and negative 2. So 2 cubed is 8, 2 squared is 4, so f of 2 is 4. F of negative 2 is going to be negative 8 minus 4, which is negative 12. So my y values are not identical, and they're not opposites, so I can immediately conclude that f is not even and f is not odd, right? So this is neither, and I don't even have to prove it, right? I can immediately conclude that neither one is true. Because the definition of even means that every single x and opposite x will produce the same y. The definition of odd is that every single x and opposite x will produce opposite y's. So I have immediately found an x and an opposite of x that don't produce the same y, don't produce opposite y's. So this is neither even nor odd. All right, so the goal of the remainder of these activities is to think about the meaning of function notation when applied to functions modeling real-world situations. So if f of t represents the annual wheat production in Argentina in millions of tons, t is measured in years since 1990, interpret the equation f of 12 equals 9. Okay, so the 12 is an input, right? So it is a t. And t is years. Okay? So that 12 represents 12 years after 1990, so I would say 2002. So I start my interpretation with in the year 2002, and then I'm going to interpret the 9. So the output of f of t is the annual wheat production in millions of tons in Argentina. So in 2002, Argentina produced 9 million tons of wheat. In the Andes Mountains in Peru, the number of species of bats present is a function of the elevation h in feet above sea level. So let n be the function, interpret the statement. Okay. So n is the function, right? And it is a function of elevation, right? So this is input. Okay. So we're looking at n is a function of h. So the 500, whatever's in parentheses, is an elevation, and then the output is number of species of bats. So this 500 is representing feet above sea level. So I'm going to say at 500 feet, there are, the output of 100 is species of bats. There are 100 species. And of 0 is 150. So the number in parentheses is an elevation. So 0 feet above sea level. So I'll just say at sea level. There are 150 species. And 20,000 feet above sea level. There are 0 species of bats. Okay, here I have a function P. It measures weekly profit in dollars that E & Co will make if they manufacture and sell X mathematical toys per week. So the graph of P is given, and we want to use the graph to answer some questions. assuming the domain of P is 0 to 500. So there is no more graph that you're not seeing. The whole graph is shown. So I want to evaluate P of 0. So that means my input, or my X, is 0. So I find my X value of 0, go down to the graph, and I get negative 800. So P of 0 equals negative 800. So what that means is that if I make 0 toys per week, or if E & Co makes 0 toys per week, then their profit is negative $800, or they lose $800. That means they're running this company with all of its expenses, but not making or selling any toys. So their profit is going to be negative. They lose money. Okay, use the graph to evaluate P of 250. So 250 is my X. It's about right here. I go up to the graph, get the Y value, looks like 400. So P of 250 equals 400. That means if you make and sell 250 toys, your profit is going to be $500. Your weekly profit is $500. I'll just make a little note. This is number of toys. This is profit dollars. All right, use the graph to find all solutions to the equation P of X equals 0. So now we're looking for where the Y value is 0. So that happens here and here. And the X values are 150 and 450. So what that means is if you manufacture and sell 150 toys, then your profit is going to be 0, breaking even. Same thing with 450 toys. If you make and sell 450 toys, your profit is going to be 0. You're just breaking even. So it might seem counterintuitive that when you make more toys, that your profit starts going down. But that's probably due to a limitation on like the factory. So the factory can only make so many toys in a week without having to pay its workers overtime or run the factory overnight, which costs more electricity, stuff like that. So it turns out that there is some optimal number of toys to make to maximize your profit, because your costs start to increase the more you run the factory. All right, on what intervals is P increasing and on what intervals is P decreasing? Okay, so remember, increasing and decreasing means read left to right, uphill or downhill, but you only give X values. So increasing from here to here, that's an uphill as you go left to right. But I only give X values. So this point right here, the X value is 0. And this point right here, the X value is 325. So I'm increasing 0 to 325. And you always give increasing and decreasing as open intervals. And then decreasing from this point to this point. And this point is 325, the X value. And this point, the X value is 500. So decreasing from 325 to 500. Which means that my optimal point happens at 325 toys per week. So that's the answer to part E. How many mathematical toys should E & Co manufacture and sell to maximize profit? 325. That's where you hit the highest profit. All right, one last question for the lesson 11 activities. Linda put a mug of water in the microwave, heated it to near boiling, put a tea bag in it, and promptly forgot it on her desk, where its temperature dropped steadily. The table below shows the temperature of the tea at various points after Linda left it on her desk. Okay, here's my function. F of t is the temperature of the tea after t minutes. And the domain is 0 to 60. 0 minutes the moment she put it on her desk to 60 minutes later. Explain how you know, based on the situation described, that F is a function. Because at any given time, your T can only be one temperature. At any given moment, the T can only have one temperature associated with it, so it is a function. Evaluate F of 30 and explain what your answer means. So we're looking, 30 is an input because it's in parentheses. So we look for 30 in our input column, and we get 41.9 degrees. And what that means is that after 30 minutes, the T is 41.9 degrees. I'm not going to write it down just to save some time, but it is written in the answers. Solve the equation, when does f of x equal 30? So now I'm looking for a temperature of 30, output of 30, and I'm looking for an x, time. So I have a spot right here where my temperature is 30, and that happens after 50 minutes. So interpret to explain what that means, that the T hits 30 degrees after 50 minutes. The range of F is the smallest temperature to the largest temperature. So we've got 26.8 to 91.2. And I'm going to include both of those endpoints because the temperature actually hits 26.8 and it actually hits 91.2. Those are parts of the range. Find the average rate of change from 0 to 60. So that rate is a speed. How fast is the temperature changing from 0 to 60? So I want to do change in temp divided by change in time, and that will give me a rate. How fast the temperature is changing over the first 60 minutes. So my temperature changes from 91.2 to 26.8. Right, and my temperature change is, my time change is 60 minutes. I'll do 0 minus 60. I have to do the same order. 91.2 happened at time 0, so I have to do the 0, then minus the 60, because the 26.8 happened at 60. All right, so I do this real quick on a calculator. (91.2 minus 26.8 is 64.4 over negative 60. So I get negative 1.073 degrees per minute. That is my average rate of change. On average, my T is changing by decreasing 1.073 degrees per minute. Okay, that finishes the class activities for lesson 11.